All right, in this video, I'm going to show an example of calculating the standard deviation and variance for a sample. So if you notice, I've already put up the formula for the standard deviation, and that's what I'm going to be calculating first. I'll address the variance once we've already calculated the standard deviation. And if you look at this formula, you're going to notice that there are a lot of parts to it. But if you remember your order of operations, here's a quick little summary of everything that we're going to do, and then I'll walk us through an actual numerical example. So if you notice, inside those parentheses, I see my symbol for the sample mean. So I'm actually going to start as an aside and quickly calculate the sample mean. From there, I'm going to need to subtract that sample mean from each one of the data values. So I'm going to set up a nice little column and do that. Again, order of operations, then we're going to do the squaring of those values. And then that symbol, we'll remember, is sigma in the Greek alphabet, and it just means summation or addition. So we're going to add up all those squared values. That'll give us our numerator. The denominator is n minus 1. N stands for the sample size, so we'll calculate that, or actually find it based on our data set. We'll do the division, we'll do the square root. So a lot going on, but if you use this little table, I think it'll work rather quickly. So as I mentioned, I'm actually going to start out with that aside, and over here I'm going to calculate the sample mean. So the sample mean is just found by adding all of our data values and dividing by the total number of values. And so here's the sample data set that I'm going to be using, 2, 3, 5, 7, and 18. So again, if I add these all up, it turns out that they actually add up to 35. And if I count, I notice I actually have 5 values. So 35 divided by 5 gives me a mean of 7. So, like I mentioned, this is actually not too bad if we start out with this little table here. And what I'm going to do is my first step, just to make it a little easier, is take this information, which is in a row, and just put it in a column. So all I'm doing is literally rewriting my 5 values. And now, just like I did when I was explaining this, I'm really just going to follow the formula. So this is going to be each value, and I'm going to subtract the value of the mean, which remember is 7. So this first one is going to be 2 minus 7 gives me negative 5. Right? 3 minus 7 gives me negative 4. And if I keep going on, right, 5 minus 7 gives me negative 2, 7 minus 7 gives me 0, and then 18 minus 7 gives me 11. Even though this formula is pretty complicated, one of the nice things that there are some safety checks. So if you notice, if I were to add these 5 values together, it actually always sums to 0. And so it's nice that I can actually stop right here, check to make sure that I'm on the right track before I move on. So negative 5 plus negative 4 plus negative 2 plus 0 plus 11 does add to 0. One little side note, in this example, my mean turned out to be a whole number. I did that on purpose, just for ease of use in this example. However, with real-world data, you may get decimal points. If you get decimal points, you are actually going to need to carry out and use all those decimal points. So you may actually get a value here with decimals that's either really close to 0, or it may actually turn out to be 0 itself. So 0 or something close if you're using decimals. So now back to my formula. I have what's inside the parentheses. Next, I want to square those values. One note here, we should know that no matter the number, when I square it, it's always going to be positive. So in this case, negative 5 times negative 5 should give me positive 25. Some calculators, you just need to be careful. You need to know whether or not you use parentheses. So just try to remember that all these values should be positive. So -4 when I square it is 16, right? -2 when I square it is 4. 0 when I square it is 0. And then 11 when I square it is 121. To jump back a second and give you some terminology, this piece right here, these are called deviations from the mean, right? How far away each one of these values is from the mean. And so this step right here, these are actually just called squared deviations. Makes it a little easier when we think about this in terms of that formula. So again, what have I done? Subtracted the mean, squared them. Last step in that numerator is to go ahead and add all these values up. So again, if I were just to take my calculator and add 25 plus 16 plus 4 plus 0 plus 121, it turns out it actually equals 166. And again, that is my numerator. All right, the denominator is not too bad. Formula n minus 1. N is equal to the number of values we have, or the number of observations. So 5 minus 1 is obviously going to give us a 4. So there's my denominator. If I want to take the time, although most calculators can do this for you, if you want though, you can go ahead and clean this up. What is 166 divided by 4? It turns out it's 41.5. And so final last step is to go ahead and take the square root. So when I put that into my calculator, the square root is going to give me 6.4420 ... A lot of decimals. A lot of calculators will give you 8 or 9 different decimals. Our rounding rules for the standard deviation, though, are to use one more decimal place than what your original data set had. So if you notice, all of the values in my original data set were whole numbers. Therefore, one more decimal place is actually just going to be 1 decimal place. So my final answer on this for the standard deviation is actually just going to be 6.4. So all that's left then is now the variance. The variance, notice I didn't put a formula on, but for our variance, our notation is actually just s squared. So how do I get the variance? All we have to do is just square the standard deviation. So the notation actually tells you exactly how to calculate the variance. I would not want to use my rounded answer because, again, I rounded that. So I would actually want to take this big number right here in all the decimal places and square it. And it turns out that's actually going to give me back that 41.5, which, if you notice, was the value of that numerator divided by the denominator. So the 41.5 came right from the formula for the standard deviation. So even though this was a pretty lengthy example in terms of the number of steps, each one of the steps is relatively simple. I really like to use this table. It allows you to just follow along and do all the pieces and really just plug into that formula. So again, this was an example of calculating the variance, which we found to be 41.5, and the standard deviation, which we found to be 6.4 for a sample.